السلام عليكم ورحمة الله وبركاته. Alhamdulillah, I'm blessed with the uh, ability to proceed and to continue with our video with regards to applied environmental sciences. And we are actually in the middle of the Clean Air Regulations 2014. We are discussing today in this video fugitive dust emission. Is it regulated? How much? Where does it come from? How is it regulated? Is it from the source of emission, or is it in the ambient air? And what sort of activity is regulated? We'll take a look into all that. Alhamdulillah. Thank you very much for coming again to this video, and for those who have subscribed to my channel, to this channel, thank you very much. All praise and for blessings to you in your undertakings in applied environmental sciences and in your future. And before we go on, please remember my warning with regards to uh, the viewing of my videos, especially for my Muslim brothers. Please do not view my video on Friday, especially when you're in the mosque and the khatib is preaching and reciting the khutbah. Please avoid that. And also all other places of worships, and in your meeting, when you have meeting with people, especially your boss, your clients, etc., your affiliates, and even when you're driving and you're riding bikes, and also when your wife calls you to go to bed. So don't bring your handphone and watch my video. That's not a good time. All right, so let us proceed now to the next slide. Now I have here for you some old pictures, classic old pictures, which is conspicuous enough to tell us the major sources of dust in our air. And when this dust are not able to be contained, the environmental law in this country called it fugitive dust, meaning it has lost containment. All right, in health safety, spillage is referred to as loss of containment, but in environmental legal application, dust, as you could see from this picture, which is actually here on the ground, all right, and it is actually scattered here on the ground, but our what they call a backhoe or prime mover come over and collect them, hoping to transport them elsewhere. But in doing so, the crude physical manner of doing so, by scooping, all these dust are being agitated and has got some of the finer particles, lighter particles of dust, has lost containment, and it flew away into the atmosphere. It becomes airborne. All right, and this is a problem with the environment. And if you could see these dust, it shows us that, according to environmental engineer whom I studied from, these dust particles are sizing perhaps more than 80 microns in size, in diameter. So they are visible. But if you look around, there are other parts. There are other parts of this particular area where you don't see dust, especially in these areas. And when dusts are smaller than 80 microns, they are no longer visible to the naked human eye. But it is there. It is airborne. And it can travel based on factors of meteorological sciences: air pressure, wind speed, wind direction, humidity, and temperature. Of course, air pressure. So those are factors that would influence where the dust would go and where would it settle. All right. So this is where dust can travel transboundary from one place to another and without having to declare anything. And dust from one industrial area can settle down in some other areas, probably remote, in villages where the dust doesn't originate from. So dust is actually uh, um, a challenge in controlling and containing. So these are some few examples, common examples of the origin of dust, particulate matter in the air. All right, so these are some of the pictures that I have. Now let's take a look at what the law. Oh yeah, if you would be interested, because I'm already starting to teach what you call responsible care, EMS 14001. This is quite popular in Europe. I think they have got uh, you know a lot of studies on this, and they've embarked. Most companies in Europe has embarked on this, and maybe some of you are studying probably environmental sciences and environmental management system. I think you are aware of this word, environmental aspect, all right, and environmental impact. So to relate this picture to this, very simple. This dust is one of those environmental aspects. As it gets into the atmosphere, into the air, it causes a state called air pollution. That is environmental impact. Having time in the future, I might get into details of this environmental aspect, and we'll look at it from the life cycle perspective in much detail. All right. So let's move on to the next slide. Now we have here, in particular, what you call the law, which is Environmental Quality Clean Air Regulations. We are right in the middle of the clean air regulation, and we are still in the second schedule. All right, and this is a control, a specific control for fugitive emissions. And in the previous video, of the video just before this, we have discussed the non-methane volatile organic carbons, the volatile organic carbons emission. There are standards. Now, in part B, this video, we are going to look what the law has got to say as far as controlling the fugitive emissions of dust. Can dust, which is that small in size in terms of particulate diameter, coming from the various processes, as far as the industrial processes are concerned, can it be controlled? Could there be a specific limit of figure imposed to industries with regards to fugitive emissions of dust? Take a look. Now, when we talk about fugitive emissions of dust, especially if I'm allowed to give some examples, I hope I don't offend anyone. All right, this video is meant for education. All right, and if it is regarding your process, please bear with me for a while and take some uh, findings as lessons learned. Okay, now let's take a look at some popular, more robust and more conspicuous, more open air sources of fugitive dust. I believe you are familiar, if not have seen, perhaps have seen while you're traveling from place to place, places like quarries. It could be a quarry for stone quarry to make materials for road building. All right, it could be quarries for bauxite, mining. It could be where sometimes you got to blast hilltops, probably normally quarry that involve blasting of hills are usually quarries in the production of stones and aggregates for construction. Probably we are talking about quarries which is involved in the exploitation of phosphate rock, probably uh, that is being used in industries, especially as raw mats in the perhaps fertilizer manufacturing. So all these are happening in the open air. Of course, once you blast rocks, you have got crushers to pulverize literally the rocks from big boulder sizes to smaller sizes, conducive enough for transport and to go into the next process like loading and transportation. This is one of the primary beginning where we can find fugitive dust emission from the open process area. Another example, maybe you like to know, perhaps related to you, probably if you're working in shipyard, you might have seen some open air sandblasting, right? Sandblasting now is no longer using copper grades. It is now probably using garnet or sand, silica, all right? Blasting of rusted surfaces, or probably removal of old paints. Then these are when it is done in the open air or open yard, would release a lot of fugitive dust into the air, and it's very difficult to contain, if not impossible. Another source of dust from similar process of blasting you can find is probably in a confined area where you have got confined blasting of fabricated metals. For example, they use an auto blast machine which is contained in a room. Now that would also be one method to control dust and also to have a very good blasting quality. Yeah, and there are many industries that releases dust which is difficult to contain. For example, in the manufacture of acid like sulfuric acid, you got sulfurs in, they call it stockpile yard, and it can be blown airborne by the wind. Simple as that. Or if you talk about dust coming from silos, hoppers, cyclone silos, in the transfer of material from transport, from cargo, from the ship, right up to to conveyors. All these activities do emit dust, which we call fugitive dust, because some of which are difficult to contain unless they use perhaps passive pressure, a very good conveyance technique. I wouldn't say confined, but a very good state-of-the-art type of conveyance with less agitation that would promote dust to be airborne. We got to be careful. Fine dust gets airborne for a simple reason. For a simple reason, they are being agitated. They are light. They could settle down given time, but before they settle down, if the velocity of air pushing them, the force is greater than the force of gravity to pull them down, they would fly. All right, and these are some samples. So from the ship to the silo to the conveyor to the factory receiving silo, and from that silo, these are all involving transfer of materials, dusty materials, and these transfer points are the points or source point of the emission of fugitive dust. So the transfer point, the transit point, actually transfer point from one stage to another of the material flow is actually areas of concern and more susceptible to air pollution due to most of this fugitive dust going airborne. On top of that, that is before getting into the factory. As it gets into the factory, it gets into some kind of storage tank, and it might be equipped with some kinds of dust collector to trap, because once you are in factory, all the regulations comes in, especially health safety, all right, confined spaces and mineral dust and all this. And for the environment, we have got to control before it gets into the factory, some other sources that you can think of is even in the making of boxes, carton box books, where we have got to do planning, shearing of all these thick cardboards. And if you talk about pulp and paper industries, from the sawmill right up to the furniture factory, you can visualize quite vividly of the nature of airborne dust called particles, dust particles from the pulp and paper industry. I think that's quite obvious. If you look into processes like more liquid processes like galvanizing, it does have dust and it is fugitive. It's electrolytic process. You've got dust coming up, popping out from the solution, and you need to have hood to tap it, to suck it and send to a scrubber. That is another control of dust. But some of them still go airborne without containment, without being trapped. Those are still fugitive dust from the sparks of the galvanizing tank. The same thing with other electrolytic processes. You can talk about metal fabrication, grinding, cutting, etc., 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 an array of processes that causes dust, including yarn factory for textile industry. Those are dusty as well. All right, there's so much. All right, there's so much in the making of tire. Talking about tire, yeah, I'm a biker, as you know. I just got brand new S22 testing the tire, and that tire comes from carbon black. And where does carbon black come from? A factory that produces carbon black is dusty. An array of dust collector is installed in factories that manufacture carbon black. And that carbon black is sent to the tire manufacturing plant, and there you have a carbon black soft compound on the side walls of your Pirelli Diablo Corsa or Battlex, whatever you're using, and it's from carbon black. And now they've got technology, hydrosilicon, to have silica on the center thread of the tire so that it lasts longer. Interesting, isn't it? So these are all dusty industrial processes. Right. It's quite lengthy, isn't it? So I believe if you are working in industries, you know what I'm talking about. But if you're a student, not yet exposed to industrial processes, after watching this video, do get some information by looking at other videos by other makers of industrial videos, so that you're able to learn more. And for university lecturers, please compile all this information, and this is a good video to help you in your teaching. You don't have time to produce what I have produced before you. You take it, you copy it. I don't reserve any copyright, remember. So I want you to spread all this to all your students, and at the same time facilitate your teaching, and at the same time you do more research as lecturers to bring in more latest information with regards to what we're talking about here. All right, so I hope that would be the way, okay, so that we can improve. Now let's go to the law now. What does it say? Regulation. What does it say? Which activity? We have discussed this. Look, these are all major sources of dust if the materials involved are dust or dusty. And these are the origins of dust emission into the ambient air and loss containment, and we call it fugitive dust. What does the law require? Take a look. Is there anything specific? Take a look. What does it say? Suitable. Meaning we got to tailor to the source of dust emission. We got to tailor whatever design that we could think of to minimize the agitation of dust that could bring in airborne and become loss containment or become fugitive dust to be contained by having a technique. And this is probably an innovation. You don't get people to produce, to sell you a product which is ready-made. We got to engineer the design because different processes have got different niche, different techniques, different equipment, different process flow, and may require different types of dust arrestor, can I call it, or dust collection technique. All right, and or probably the process technique itself, the transfer technique, the hoisting technique has got to be re-engineered, if I may say that, to ensure less dust becomes fugitive, literally. All right. Now, what else? The law says shall be made by DOE. No, it doesn't work that way. This is just a legal literacy. What happened is you come up with a drawing, you come up with a design, as I mentioned earlier, process layout, factory layout are all given, and that innovative design has got to be engineered and drawn with on a blueprint and endorsed by a professional engineer certified under Board of Engineers Malaysia, and then submit to DOE in the form called notification. Notification to install equipment to reduce the emissions of fugitive dust under Regulation 13, Second Schedule, Part 3, Subclause B. So that's it. And it's up to DOE to approve it or not. If they are quiet, just proceed. So notification, after you send the drawing, you got to build within 30 days. All right, send in that notification. You are considered done. You have done your part as far as the law requirement is concerned. All right, do not have to wait for DOE to reply. Okay, they will come. Okay, and to do a verification inspection, and then look, very subjectively, good housekeeping in an electronic company versus good housekeeping in the furniture factory. Different thing, isn't it? So these are all depending on what have you got for your process material, process technique, raw mat, and product. And you got to arrest all the points where dust is coming out and to be the source of air pollutants. Okay, and you got to audit all these processes and identify all the points of weakness in the sense that the weakness points are where the dust are being emitted out as fugitive dust. Address that area, put your energy there, think how to improve uh, the process, the flow, the machines, etc. Now, mark my words, consult your foremen, your operators. Do not be surprised if there are many of them who are working there knows what to suggest. As engineers, you are perhaps white collar staff, but if you don't have that many years of experience, consult those people under you, learn from them. Okay, and normally, as far as my experience is concerned, more than 80% of the suggestions come from them, but we translate it into blueprints and designed by contractors, but the idea was from them. Only a handful of them are being credited. All right, honestly. Okay, so we have to pay good regards uh, for these people who are working there and give them the chance to give an input. They will come up with something sometimes miraculous. All right, so this is about it for regulation 13. What I have here is a very common picture. Hoses. Look, it is from this plant over here. So very similar. So sometimes in production we just leave it there waiting for maintenance to come. My friend, it doesn't work that way. Every morning we have got a round trip, right? The entire factory, we got to address all this quickly. Do not have to wait, otherwise it becomes fugitive dust and it can be hazardous, as you know by now. All right, so I believe that's about it for this video on how fugitive dust is being legalized by the Clean Air Regulation 2014 of the Malaysian Environmental Quality Act 1974. So this is second schedule of the law, part 3 and subclause B, fugitive emissions of dust. I hope it's clear enough for you, and I hope you know what to do. So if you do not know what to do, here, all this convert it into your SOP or work instruction sheet. All right, so that will be, once it is approved by DOE, it will be your operational procedure. All right, then hopefully you were able to settle that fugitive dust problem. Thank you again for your attention. Please do not forget to subscribe, share, and like this video. Please send it to people who might need it. So this is the best I could do for the moment. Thank you for your attention again. I wish everybody Assalamu alaikum warahmatullahi wabarakatuh. Have a nice day and enjoy your learning. Bye-bye.